Okay, we're going to take a look at Explore number 5 from our Living Earth text. We're in Unit 2, Concept number 1, Explore number 5. So 2.1.5. Go ahead and write that out. Draw your template here, put your date down, and go ahead and write down the essential question we're trying to answer. We're trying to understand redox reactions, especially oxidation versus reduction. So go ahead and take a moment, write down what you know, what you think. Okay, hopefully you took a moment to do that. We'll start with Roman numeral 1. Okay, redox reactions. Redox, as you know, is shorthand for reduction and oxidation, right? The portion here that's the RED, this is reduction. And the ox part is the oxidation. When you have any chemical reactions, um, usually you're going to be having an exchange of charge. One is going to lose a charge or lose an electron, and another one is going to gain a charge or gain an electron. So that's why almost all of your reactions are going to be redox reactions. In living systems, this serves as a way to store energy. Um, if you're not going to use the energy right away. And it also serves as a way to release energy. Okay, and that's what we have written down there for A. So let's take a look here. We've got an example. We have an element that has 3 protons, and you know that in the first shell, the first orbital, it can take a maximum of 2 electrons. So we have a second orbital that has our third electron. Because that third electron is in the second orbital, it's at a higher energy level, okay, versus the 2 that are near the nucleus. Those are at a lower energy level. Now, you know that the valence in the second shell is full when it has 8 electrons. So it's probably more likely that this is going to donate or give away its electron in a chemical reaction to gain stability. And when it loses that electron, if you remember, losing the electrons, we had that expression, Leo the lion says, "Grr, lose electrons is oxidation." So this is an oxidation reaction. When it loses that electron, it's also releasing energy. Okay. Now you also have to get comfortable with the idea that of oxidation numbers. In this particular case, the oxidation number will change, right? In this case, um, it'll have a 1 plus charge because there are 3 positive protons in the middle. And since it gave away one of its 3 electrons, now it only has 2 electrons. So it has a net 1 plus charge. So in this top example here, we have an oxidation that's occurred. If we go down to perhaps the element that it's reacting with, you can count the number of protons in the middle, all those little plus signs, 1, 2, 3, 4, 5, 6, 7, 8, 9 protons. So we went ahead and put 2 electrons in the first shell because that's the maximum it can take. And then we went ahead and put the additional 7 into the second shell. Now remember, it would prefer to have 8 to have a full valence. It's most likely going to accept an electron from some donor, from some other element. And in gaining that electron, remember we said Leo the lion says grr, gaining electrons is reduction. So if this were to gain the electron, um, well, now it's going to have an additional electron. So it's now going to have, if you had 1, 2, 3, 4, 5, 6, 7, 8, if you had 9 protons, now you have 10 electrons. If you add that up, 9 positives plus 10 negatives, you have gained a negative charge. So your oxidation number is 1 negative, okay, 1 minus. So in this particular example, you have a reduction that has occurred, okay? Now remember, in so doing, by gaining this electron, you have effectively increased your potential energy. All right, by gaining electrons, you have increased your potential energy. And that's how a lot of what happens in life, in our biological systems, this is how energy is transferred. Charges are transferred. We call these redox reactions, and they usually happen simultaneously. It is a transfer of charge that is occurring. All right, so the top one was oxidized, the bottom one was reduced, and in total, this was a redox reaction. Okay. All right. Well, that was it. I think maybe what we should do here is just maybe we should write this expression down in case you have not done that yet. Leo, the lion, says grr, right? And for Leo, the lion, this is lose electron is oxidation. Okay. Right? Lose electron oxidation. That's Leo. And to gain electron, we say that this is reduction. And that's where we say GER, G-E-N-R. Okay, and this is GER. All right, and this is just a mnemonic. This is just something to help you remember, right? This is a mnemonic. A mnemonic to help you remember. Right? You can make up your own mnemonic. There's nothing that says you have to use this one. But I hope that that helps. I saw a number of you guys writing that down. So I think that a number of you are seeing the value in that. So what I want you to do right now is just write a summary paragraph. Okay? In your own words. Remember, try to be specific. All right? That's only going to help you. And we'll talk to you soon. Bye-bye.